This tutorial is about formulas of compounds, which is also known as writing formulas or formula writing. A compound, as you learned in the last chapter, is composed of two or more different atoms that are bonded together. That's the important part, is they're bonded together. You can write a formula to represent a compound. You know of a formula, or actually you know of probably many of them. Water has a formula, it is H2O. Carbon monoxide has a formula, it is CO. Sodium chloride is the formula of table salt. So you have seen the formula around, you just probably haven't realized it was called a formula. A formula always contains the same relative number of atoms of each element. So let's take a look at what that means seen here with water. There are always two H's for every one O if you want to have the molecule of water. It does not have three H's and four O's. So it always two H's and one O. The minute you change the number of elements you have a different substance. So as you noticed, I mentioned something about this little subscript there, and that's what we're going to talk about next. Before we talk about the subscript, let's just remember that, as I said before, a chemical formula is just a way to express a compound. So like we said, H2O is the chemical formula for water. What is the chemical formula, or just saying the word formula is also okay, for salt? NaCl, correct. Hopefully those you know. So in order to look at formulas closer, we should know how to count the atoms that are in a formula. So not only is H and O are they called elements, but remember, any type of matter, whether they're elements, compounds, mixtures, they're all made up of atoms. So I can say I have atoms, or I could say I have elements in this example that I circled. The subscripts, right, this is a subscript right here, are the little numbers, and they tell us how many atoms there are of the element that it's attached to. So the element in the front of it. So there are two H's. If you notice, oxygen has no subscript, because when the subscript is 1, right, 1 oxygen, it is not written. It is an invisible 1. So there are two H's and 1 oxygen. So, seen in this compound, I have S bonding to O, making a compound. And actually, if you notice, there's 1 S and 3 O's. So another way of saying it is there's 1 sulfur atom and 3 oxygen atoms. Sulfur and oxygen are different atoms being bonded together. Different elements bonded together. That is the definition of a compound. It's also a definition of a molecule. And this is the formula that represents it. The name is sulfur trioxide, but we're not focusing on the name, we're focusing on how to look at a formula and understand what it means. Now let's take a look at some other examples. The first example should look very familiar to you. C6H12O6, that's glucose. If you notice, I have carbons, hydrogens, and oxygens bonded together. There's a compound. There are 6 carbons, 12 hydrogens, and 6 oxygens. Another way of saying it is 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen, all bonded together. Now this example is a little different. There's a parentheses. So think about math and distributing. That's exactly what you're going to do here. The parentheses is only pertaining to the OH, and the 2 only is going to be applied to what is in the parentheses. Again, just like math. So I have 1 atom of Ba, because it is not inside the parentheses. I have 2 atoms of O and 2 atoms of H. Distribute the 2 like you would do in math. Another thing I could say is I have 2 of the OH's in the parenthesis. Why don't we try this example? A molecule contains 4 phosphorus atoms and 10 oxygen atoms. Go ahead and try to see if you can do this. Pause the slide. The answer to this is you first want to figure out what you have. Phosphorus is represented by the letter P, and there are 4 of them. There you go. It goes after the elements symbol. And 10 oxygens. It's a molecule, so bring them close together because they bonded, and there's 10 of them. There you go. There's your formula, P4O10. 4 phosphorus, 10 oxygens.